Hi, today's topic is divide monomials. Mono means one, so divide monomials mean we divide one term to another. Okay, so for the first learning objective, we're going to learn how to simplify expression using quotient properties for exponents. And for the second objective, we're going to go through some problems how to divide monomials. Okay. If I have the expression x to the 7 divided by x to the 4, I can write this quotient as for the top x to the 7, I can write out x times itself 7 times, right? So x times x times x times x times x times x times x, right? 7 times. Similarly, for the denominator, and I can write out x times itself 4 times. Right? So x times x times x times x. Right, and then we can do some simplification here, right? So I can simplify this x with this x, this x with this x, this one with this one, and this one with this one, right? Now, when you divide something on the top with the same thing on the bottom, it doesn't mean that it disappears. Right? It doesn't mean that it becomes nothing. It basically, if, for example, if I divide a by a, right, which is this is simplified as 1 over 1, right? Or sometimes we write 1, right? But it doesn't mean that it disappeared. So for the first pair, x divided by x is simply 1 over 1, right? The second pair is 1 over 1, third pair 1 over 1, and the last pair is 1 over 1, right? And the tops I have 1 times 1 times 1 times 1 4 times, and 1 times 1 times 1 times 1, that's just 1, right? And the time with the x before that, so usually we don't write the 1 out, right? So it's just x times x times x. So what is left on the numerator? Okay. On the bottom, however, you're gonna write it in. You're gonna write that 1 in, right? Because it doesn't mean that it's when you divide, it disappear, right? It become nothing. So you're gonna write that 1 in. So it become x to the third. So x times x, according to the product rules. You can check out my previous video for that. This is x to the first times x to the first times x to the first. Right, so according to the product rules, if you have the same base and they multiply together, all you have to do is you add the exponents, right? So 1 plus 1 plus 1 is 3, so which is equal to x to the third over 1, which is x to the third. Okay. Okay, so the relationship, as you can see, the relationship between the exponents of x to the 7 divided by x to the 4 and x to the third is, I see that the exponent of 3 is the difference between the exponents of 7 and exponents of 4, right? So let me write it out. So exponents of 3 is the difference of exponent of 7 and exponent of 4. Okay, so 7 minus 4 equals 3. All right. Okay, so same thing. If I flip the quotient, now I have x to the 4 divided by x to the 7. Notice that the degree of the denominator is larger than the degree of the numerator now, right? So again, same argument. You can write out x 4 times on the top, and then x times itself 7 times on the bottom. Simplify, I have x 1 over x times x, which equal to 1 over x cubed. Okay. So if I have if I have a larger degree or exponents in the denominator, then my factors are left in the denominator. So the answer here is in the denominator. As you can see, if I have x to the 4 divided by x to the 7, the final result is 1 over x to the third. So x to the third is in the denominator, right? Why? Because to avoid the negative exponents, you take 7, subtract 4, and because 7 is bigger than 4, therefore the factor is in the denominator. Okay. All right, so now it comes to the quotient property. Last time we talked about product properties, now the quotient properties. Let A represent a non-zero real number, and M and N represent the positive integer. Then A to the M divided by A to the N equal to A to the N minus N. Right? If M is bigger than N, so if the degree of the numerator is bigger than the degree of the denominator, then the factor of a's remain in the numerator. Right? So basically, if you have a to the m divided by a to the n, it is equal to a to the n minus n. Well, this is over 1, right? But again, when you write a quotient, you have like something over 1. Usually we don't write it, right? We just write that number. Okay, and for the case that if you have the degree in the denominator is larger than the degree of the numerator, then the factor of a remain in the denominator. Okay, so a to the m divided by a to the n equal to 1 over n minus m. Okay, always take the bigger number, subtract the smaller the number. Okay. All right, so let's simplify some expression. I have x to the 11 divided by x to the third, right? So this is obvious. The first case is when the degree of the numerator is bigger than the degree of the denominator. So this case, right? So this is the first case, right? So what do? We take equal x to the 11, subtract 3, right? 11 minus 3 is 8, so it's equal to x to the 8. Problem B, x to the third divided by x to the 11. Since the degree in the denominator is larger than the degree in the numerator, then this is obviously the second case, right? So that's the case. Equal, so this is equal to 1 over x to the 11 minus 3. Well, 11 minus 3 is 8, so it's 1 over x to the 8 power. Okay. All right, see, I have 15x minus y to the 11th power divided by 15x minus y to the first power, right? Since usually the first power is not written there, but we know that there's a 1 there, okay? So this is equal to, I know it looked a little bit more complicated than the previous two, but it's the same thing, right? Because we have the same base, divided by the same base. So we can apply the quotient rule, right? So this is equal to 15x minus y to the 11 minus 1, right? Since the degree of the top is bigger than the degree of the bottom, this is first rule, right? So it's equal to 15x minus y to the 10. Okay. Now, one thing I gotta say is here, I see a lot of people do this. They see 15x on the top and 15x on the bottom, so they automatically reduce that. And then same thing, they see y on the top and then y on the bottom, and then they cancel that too. But this is totally wrong. Okay, please do not do that. Why? Because the 15x minus y divided by 15x minus y, the two terms are combined to each other. You see plus and minus, meaning the terms are combining. You cannot do that. If they multiply, then yes, right? If they multiply, then yes, you can cancel the same term on the top to the same term on the bottom. But since they combine, we cannot do that. Okay, it's a very, very popular mistake. Objective 2, like I said, we're gonna learn how to divide monomials. Right, so this is a little bit more complicated than the first one, but it's not so bad, right? So I have x to the 4 times y to the 4 divided by x to the 6 times y to the 7. Now, what I'm going to do is I'm going to break this quotient into little quotients, right? So I'm going to break the x divided by the x and the y divided by the y, right? So I'm going to have x to the 4 divided by x to the 6 times y to the 4 divided by y to the 7. Okay, now I can simplify the x separately and simplify the y separately. Okay, so x to the 4 divided by x to the 6. The degree of the denominator is bigger than the degree of the numerator. So this is equal 1 over x to the 6 minus 4, which is 1 over x squared. 1 over x squared. Times y to the 4 divided by y to the 7. So again, the exponents of the denominator is bigger than the exponents of the numerator. So it's 1 over y to the 7 minus 4, which is 1 over y to the cube. Okay, and now you may rewrite it to make it a little bit neater. So this is 1 times 1 is 1 x squared times y to the 3rd in the bottom. Okay, problem 4b, I have 45 times x to the 15 times y to the 1st. Now, I recommend if you don't see anything on the top of that term, I recommend you put the 1 there, okay? You put the 1 there, so you don't mistake it with 0, right? Divided by 9 times x to the 20 times y to the 4. Again, I'm gonna do the same thing as I did in problem A. I'm gonna break it into smaller fractions. So I'm gonna break it up, the constant with the constant, the x with the x, and the y divided by with the y. So 45 divided by 9 times x to the 15 divided by x to the 20 times y to the 1st divided by y to the 4. 45 divided by 9 is 5, or 5 over 1. Okay. Times x to the 15 divided by x to the 20. Again, the degree of the denominator is bigger than the degree of the numerator. So this is 1 over x to the 20 minus 15, right? Times y to the 1st divided by y to the 4. So it's 1 over y to the 4 minus 1. This is equal to 5 over 1 times 1 over x to the 20 minus 15 is x to the 5th, times 1 over y to the 4 minus 1 is 1 over y to the 3rd. Right, so on the top, 5 times 1, which is 5. On the bottom, 1 times x to the 5th times y to the 3rd. So x to the 5th, y to the 3rd. Thank you for watching.